Follow test 2 algebra part 2. Question 4. Determine whether each of the following functions is even, odd function or otherwise. We start with A. Here we have f1 of x equals x cosine x. So in the solution we substitute x by negative x. So we have f1 of negative x equals negative x cosine negative x, and we write it f1 of x equals x cosine x, then f1 of negative x equals negative x cosine negative x, and the value of cosine negative x is cosine x, as cosine negative x is even function. So cosine negative x equals cosine x, and we write it. So we have f1 of negative x equals negative x cosine x, and x cosine x equals f1 of x itself. So f1 of negative x equals negative f1 of x, and this means that f1 of x is odd function. B. f2 of x equals x square when x is greater than or equal 0, and f2 of x equals absolute of x when x is less than 0. We will substitute x by negative x. So f of negative x equals negative x all power 2. Instead of x, we substitute negative x. So we have negative x all power 2 when negative x is greater than 0. We substitute x equals negative x. And here again we substitute x equals negative x. So we got absolute of negative x when negative x is less than 0. And we simplify this form. So we have negative x all power 2 equals x power 2 when here negative x greater than 0, multiplying both sides by negative 1, we get x is less than or equal 0, because when you multiply the inequality by negative 1 or you divide by negative 1, the direction of inequality will be changed. So it will be x less than or equal 0, and the absolute of negative x equals the absolute of x. For example, if you have absolute of negative 2, you will get absolute of 2. It is the same, equal. When here we want to change negative x to positive x, so multiplying both sides by negative 1. So negative 1 multiply negative x equals x. Negative 1 multiply 0 equals 0. And the direction of inequality will be changed. Here we have negative x less than 0. It became x greater than 0. And this form not equal to f2 of x, because f2 of x itself, here x square when x is greater than or equal 0. But what we got here x square and x less than 0. Also with respect to the second branch, we have in the original function absolute of x when x less than 0, but here x is greater than 0. So the new form of f of negative x not equal to f2 of x. So f2 of x is not odd, also it is not even. So we write f2 of x is otherwise. Again, you can write f2 of x is neither odd nor even function. And now we discuss f3 of x. f3 of x equals x square absolute x minus 1. Substituting x equals negative x. What we got? f3 of x of negative x equals, instead of x we write negative x, so we have negative x power 2. Instead of x we write negative x minus 1, we write it. So it is the same form but changing x to be negative x. Substituting every x equals negative x, and we simplify. It is equal negative x all power 2 equals positive x power 2. Absolute of negative x equals absolute of x minus 1. So f of negative x equals x square absolute of x minus 1. It is the same f of x. So what we got? We got f3 of negative x equals f3x. And what that mean? That mean f of x, the original function, is an even function. Find in R the solution set of each of the following: absolute of x plus x equals 0, and absolute of 2x minus 3 minus absolute of 6 minus 4x is greater than 0. The required here is to find the solution set. Solution set must be satisfies the equation. Solution set is the values of x which satisfy the equation. We write it again: absolute of x plus x equals 0, and we redefine the function according to the values of absolute of x. Absolute of x equals negative x when x is less than 0. So we start when x is less than 0. Again, absolute of x equals negative x. So we have negative x plus x equals 0. So negative x plus x, it is equal 0. So 0 equals 0 in this interval. And we write it 0 equals 0. It's satisfied for any x belong to this interval, negative infinity to 0. This inequality, you can write it in the form of interval from negative infinity to 0, and it's open, of course. So this is the solution set when x is less than 0. Now we check for x is greater than or equal 0, because absolute of x, it is equals negative x when x less than 0, and the absolute of x equals the positive x when x is greater than or equal 0, and we substitute absolute of x with x. So we got, instead of absolute of x, we write positive x. So we have positive x plus x equals 0. X plus x equals 2x equals 0. What is the solution of this equation? When 2x equals 0, then x equals 0. And 0 belongs to the interval 0 to infinity. This inequality written in the form of interval. So the solution for this part is 0, and 0 belong to this inequality, belong to the interval 0 to infinity. It is closed because we have x is greater than or equal. Here there is no equal. Here x not equal 0, but in this part x equals 0. And the solution set will be the union of the two solutions. The first solution is the interval negative infinity to 0, and the second solution is 0. Here, this is 0. And 0 union negative infinity to 0 equals this interval negative infinity to 0 closed. Here it is open. When you add 0 for this interval, so we have closed 0. B, absolute of 2x minus 3 minus absolute of 6 minus 4x is greater than 0. So we write it again. Negative, negative, we take negative 2 from here as a common factor. We take negative 2 as a common factor here, negative 2, and we write it again. 6 divide negative 2 equals negative 3. 4x divide negative 2 equals 2x. The new absolute equals the original one. Multiplying negative 2 by 2x equals negative 4x. Multiplying negative 2 by negative 3 equals positive 6. And we write it again on the form. We have 2x minus 3, 2x minus 3, minus is minus, and we take 2 out, it will be negative 2, and we have absolute of negative 2x minus 3 equals absolute of 2x minus 3. What happened here? The negative will be positive inside the modulus, inside the absolute. So we have the same form here, and we can say absolute of 2x minus 3 minus 2 absolute of 2x minus 3, it is the same, equals the negative absolute of 2x minus 3, it is greater than 0. So the result of left side equals negative 2x minus 3, which is greater than 0. Multiplying both sides by negative 1, so we have 2x minus 3 less than 0. We will change the direction of inequality. Instead of greater than, it will be less than. And we solve this inequality to be phi. Solution set equals phi. Because the absolute, the value of any absolute, always positive. There is no result there is no values to x to make the absolute is negative. So when the absolute is negative, less than 0 means negative. It means the solution set equals phi, because it is impossible to be the absolute is negative. Question 5. If f of x equals x squared minus 1, g of x equals x plus 1, then graph the function f over gx showing its domain, the range, and its monotony. Solution: f over g of x equals f of x, which equal x squared minus 1, over g, which equal x plus 1. Here from the given, f of x equals x squared minus 1, and g of x equals x plus 1. And we divide x squared minus 1 over x plus 1. And we simplify it by factorization. X squared minus 1 is x minus 1 multiply x plus 1 over the same denominator. And we write the domain of the fraction. The domain equals are difference negative 1. Because when you put x equals negative 1 in the denominator, you got 0 in the denominator. And the division by 0 is meaningless. So the domain equals are difference -1. And here this is the first required, the domain. And we simplify it. F of x equals x minus 2. How we simplify it? We have x plus 1 divide x plus 1 equals 1. And we draw the new function f over g of x equals x minus 1. Substituting x equal 0, what we get here? Substituting x equals 0, so we have f over g of x equals -1. When x equals 0, the new function, the quotient, equals -1. Once x equal 1, so the new function equals 0, 1 and 0, 2 and 1, and so on, and we'll draw this straight line. So this graph represents f over g of x, which equal x minus 1. And don't forget to put a circle around -1 and -2, because the function is not defined when x equals -1. From the beginning here, the domain equals r difference -1. So the function is not defined when x equals -1. What is the value of f over g when x equals -1? It is -2. So we put a circle to express this, that the function not defined, not exist when x equals -1 and y equals -2. Substituting x equals -1 in this part. So we draw the function, and the range equals all the values of y except y equals -2. So the range equals r difference -2. And the function is increasing on its domain. As x is increasing, y always increasing. The function is increasing on its domain. So the function is increasing when x belongs to this interval. When x belongs to r, all the set of real numbers except -1. 2. Without using calculator, find the value of logarithm 25 plus log 8 multiply log 16 over log 64. Solution. We write it again. Logarithm 25. We write it logarithm 25, but logarithm 8 equals logarithm 2 power 3. As 2 power 3 equals 8. 2 multiply 2 multiply 2 equals 8. So we write it logarithm 2 power 3. Don't forget that the base here is 10. It is a common logarithm. Multiplying logarithm 2 power 4 as 16 equals 2 power 4 over logarithm 64, we write it 2 power 6 as 2 power 6 equals 64. So we have logarithm 25. We will not change it, and we're using the property of the power. Logarithm 2 power 3 equals 3 logarithm 2. 3 logarithm 2. And the logarithm 2 power 4 equals 4 logarithm 2. Logarithm 2 power 6 equals 6 logarithm 2. And we simplify this part. We can cancel log 2 over log 2 equals 1. And what we get, 3 multiply 4, it's 12. 12 logarithm 2 divide 6 equals 2 logarithm 2. And we write it logarithm 25 is the same. 3 logarithm 2 multiply 4 divide 6. 3 multiply 4 equals 12. 12 divide 6 equals 2. Logarithm 2. This logarithm 2. And you change the form of addition to multiplication. So logarithm 25 plus 2 logarithm 2 equals logarithm 5 again, plus we write it logarithm 2 power 2. 2 logarithm 2 equals logarithm 2 power 2. We put the power over 2 here. And logarithm 25 plus logarithm, this is logarithm 4, equals logarithm 25 multiply 4. So we write logarithm 25 multiply 4. So the result will be logarithm 100. 25 multiply 4 equals 100. And 100 is 10 power 2. And we write it again using the property of the power. It will be equal to logarithm 10, and the logarithm 10 equals 1. As the base of this logarithm here equals 10. So logarithm 10 to the base 10 equals 1. And the result will be 2 multiply 1 equals 2.